All right, let's look at the root test. Root test is very similar to a ratio test. And what we do is instead of taking the ratio between two consecutive terms for ratio test, we're going to actually take the nth root of the term of the nth term, right? So we take the limit of nth root of absolute value of an as n approaches infinity. Right, the conclusion we make is exactly the same as a ratio test. If the root, nth root, comes out to be -1, less than 1, then series is absolutely convergent. Right? If this root came out to be exactly equal to 1, again, this is unfortunate, it's inconclusive. So we can't say anything. It could converge or diverge. If this root came out to be greater than 1, then we know that the series diverges. Right? All right, so let's apply this root test to the following example to see if we can make a conclusion. All right, so we have this guy right here. This is going to be our an. All right, this is going to be our an. Right, so we're going to take the limit of the nth root of the absolute value. The reason why we're taking the absolute value is that so that we don't have to worry about the negative sign, right? As n, a negative number inside the root. All right. All right, so let's do that. So an is given here, so we have a limit n approaches infinity, right? In this particular case, absolute value sign doesn't really do anything because none of the term becomes actually negative. So I'm going to actually remove the absolute value sign in this case. So we have nth root of quantity 3n squared over 1 plus 2n squared raise it to the nth power. All right. So you have nth power and nth root, so we can cancel them out. So we can cancel nth root and the nth power, right? Then we just need to take the limit of 3n squared over 1 minus 2 to the n squared. All right, so what we're going to do is I'm going to multiply top and bottom by 1 over n squared. 1 over n squared. Right? I usually look for the denominator, highest power in the denominator, so which is n squared. So I divide top and bottom by n squared. Right? So this is going to be equal to limit as n approaches infinity. Right? So top is going to be 3n squared divided by n squared would be just 3 on top. On the bottom, 1 divided by 1 over divided by n squared is 1 over n squared. Plus 2n squared divided by n squared is going to be just 2. Right? As n approaches infinity, 1 over n squared, because 1 over a really big number is going to approach 0. So what's left is 3 over 2. So you have 3 over 2, which is greater than 1. So therefore, we know that this series is divergent. Right? So that's how we use the ratio test, the root test, to determine the convergence or divergence of a given series. Right? So you can see that this is very similar to a ratio test. So root tests and the ratio tests are very, very similar. Right? That's it. I hope that this was clear.